This recording will illustrate sampling distribution and central limit theorem. The problem is this. The mean height of women in a certain age group in the US is mu equal to 64 inches. A random sample of 60 women in the same age group is selected. What is the probability that x bar, the mean height of the sample, is greater than 66 inches? Assume sigma is 2.75. Elaborate further on the probability obtained. First, let's recall sampling and central limit theorem. In particular, if x bar is the mean of a random sample of size n from an infinite population with mean mu and standard deviation of sigma, and the sample size n is large enough, then z equal to x bar minus mu over sigma divided by square root n has approximately the standard normal distribution. When is the sample size large enough to apply central limit theorem? In practice, the central limit theorem is applied when one of the following is true. For example, when the population distribution is approximately normal, or for an infinite population when the sample size n is greater than or equal to 30. Let's look at the problem again. Our problem, we have the mean height of women in a certain group is 64 inches. A random sample of 60 women in the same group was selected, and assume that sigma is 2.75. What is the probability that x bar, the mean height of a sample, is greater than 66? According to the central limit theorem, z equal to x bar minus mu over sigma over square root n is standard normal, approximately. So we are looking for the probability of x bar greater than 66. We are looking for the probability of x bar greater than 66. This is the same as the probability of z greater than 66 minus 64 over 2.75 over square root of 60 by substituting mu, sigma, and n. And in the end, we have the probability of z greater than 5.63. So what is this probability now? If we draw the standard normal curve, where the center is 0, then usually standard normal curve where standard deviation is 1. This is how it looks like. So we are looking for the probability that area which beyond 5.63. So the area we are looking for is this piece. How big is this area? If you check the table, you will find that our standard normal table, z goes from 0.0 all the way to 3.99. 3.99, and at the point z equals 3.99, the area from 0 to 3.99 is 0.5. That means, if you look at standard normal curve, all the way from 0 to 3.99, this area is 0.5 all the way to 3.99. So if this area is 0.5 according to the table, then what is the area after 3.99 at the tail? That's 0, right? Therefore, from here we know the probability of z greater than 5.63 must be 0 now, because nothing left. Right? We have the area from 0 to 3.99 is 0.5 already, so there's no more area after 3.99. So the probability of z greater than 5.63 must be 0. If you have a calculator with p, q, and r function, you can also check by using calculator that r 5.63. you'll find that this number is also 0. So, go back to the problem now. The probability that z greater than 5.63 is 0. So what does that mean now? That means that it is impossible for a group of 60 women where the mean height is greater than 66 inches, given that mu is 64 and standard deviation is 2.75. That's the end of the recording.